Hi everyone, today I'm going to talk about solving systems of linear equations, and this is for the SPED 615 class at Mankato State University. Um, and yeah, we're going to just talk a little bit about three different ways you can solve for a linear equation, um, and hopefully you can decide which method you resonate the most with. And yeah, right here we have two lines that intersect and they both meet at the point 2 comma 1. This is the solution to those two lines or those two systems of equations. So 2 comma 1 is the solution. So when a question is asking you to solve for a system of equation, it'll either give you an image of the two lines on a graph, or more commonly, you'll get two equations and you'll have to solve for the solution. So systems of equations can be found by graphing, and you can either plot points or just use the slope and y-intercept. And the third solution is to solve algebraically. Systems of equations are defined as a collection of two or more linear equations that have the same variables. Basically, I like to think of this as where the two lines meet up and where they intersect. And it's the exact point. So now we're going to look at these two equations and we're going to solve for the solution in these three different ways. So we have y equals 2x plus 1 and y equals negative x plus 4. First, we're going to need some graph paper. Here I already have some graph paper lined out. You can imagine each block as one unit, so I won't go ahead and label every single um, line. You'll just assume that each of these squares is one unit. So first, I have chosen to work with y equals 2x plus 1. And how we are going to find the solutions for this one is by plugging in several different numbers for x into x plus 1. So first we'll start with 0. 0 is a great one to start with, and then we'll go up to about 3. So on the table below, you can fill out 0, 1, 2, and 3 for x, and that's when we'll plug in these 4 points and get a y. So when we plug in 0 for 2x plus 1, we'll get so first we'll plug it in, and then we get 2 times 0 plus 1. 2 times 0 is 0 plus 1. So our first solution is y equals 1. I'll do one more with you, and then I'll have you solve the rest. So for the next one, we have 1, so we'll plug in 1 into 2x. So 1 times 2 is 2, and that 2 plus 1 is 3. So then our next solution is 1, 3. Now I'll go ahead and finish these ones out. So for the remainders, I got 2 comma 5, and then I got 3 comma 7. And I'm going to go ahead and plot these points actually first. So we have 0 comma 1, so over 0 up 1. Then we have 1 comma 3 over 1 up 3. Then we have 2 comma 5, so over 2 up 5. And then we have 3, 7, so over 3 up 7. For our blue line, that's the color I've chosen, we will do the same thing. So 0, 1, 2, and 3. You can just kind of pick these numbers. I like to start with 0 because when x equals 0, that's when we'll be able to find the y-intercept. So starting at 0 is a good way to start. So I have 0, so we plug in 0 for negative x plus 4. 0 times negative 1 is 0, plus 4 gives us 4. So 0 comma 4 is our first point. Then I will solve for our next point, which is 1. So we'll plug in 1 for negative x plus 4. So 1 plugging in for negative x becomes negative 1. So negative 1 plus 4 equals 3. So our next point is 1 comma 3. After you have all those points filled out, which we have 2 comma 2 and then 3 comma 1, you'll go ahead and plot all those points down like we did before. And then when you finish, you'll draw a line through it. As you can see, the lines have intersected at 1 comma 3. And if you look at the table, x, when x is 1, y is 3 for both situations. So it's safe to say that 1 comma 3 is the solution to these two systems of equations. Now we're going to move into slope-intercept form. With slope-intercept form, you're going to have to remember where the slope is. So y equals mx plus b, m is the slope. Slope is also known as rise over run. And the b is our y-intercept. It's a little cut off in the video, but I've labeled b as y-intercept. So if we look at our first equation, so our y-intercept is where the line intersects on the y-intercept there. So I'm going to highlight it. That's our y-intercept, where the line crosses through there. And the y-intercept is when x equals 0 as well. So looking at this first equation, our y-intercept is 1. So we can go ahead and plot the y-intercept. Over 0 up 1. Now we have our slope, which is 2. Slope is also known as rise over run, so this also means 2 over 1. If your slope is just 2, then it's going to be 2 over 1. So our rise is 2 and our run is 1. So that will be looking like that. And I like to do the stair method. So now we will do the blue line. So we have y equals negative x plus 4. Our y-intercept is 4, so that's going to be over 0 up 4. So you can go ahead and plot that y-intercept on that line. And then our slope is negative x, which also is known as negative 1. So our slope is negative 1. And to kind of break that down, that means it's negative 1 times the x. So whatever is whatever x is, it'll become negative. So this line will be decreasing and it'll be going in a downward direction. So definitely will intersect. So if our slope is negative 1, that means our rise and run will be negative 1. So it'll drop 1 and then go over 1. And you'll see the little staircase there. Now in this situation, it looks like our system of equation is also 1 comma 3. So that confirms our last problem when we solved for the system of equation. We got 1 comma 3. So I want you to take a look at these two problems and notice that they're both set equal to y. And because of that, that means we can set these two problems equal to each other and solve for the x variable. This method is called substitution. So because we know that y equals negative x plus 4 and y equals 2x plus 1, we can assume that these two problems can equal each other. So we'll solve it to confirm that that works, which is what I'm going to do now. So negative x plus 4 equals 2x plus 1. So we want to get x by itself. So what I have chosen to do first is add x to both sides. And then x cancels out on the left, and then the 4 drops down, so it becomes 4 equals 3x plus 1. And then next we will want to take away 1 from both sides so that x is still by itself. So it becomes 3 equals 3x. And finally, we will want to get x by itself still, so we want to divide 3 from both sides. And we will get that x equals 1. Now, x equals 1 means we will have to plug in this solution to both problems to confirm that the y is the same. So we're going to plug in x for both equations, starting with the one on the left. So we plug in 1, and it becomes, and then I'll write it over here too, y equals 2 times 1 plus 1. So let's solve the one on the left first. Negative 1 plus 4, y equals 3. And then 2 plus 1 also equals 3. So we get that x equals 1 and y equals 3, which confirms our original answer, which was 1 comma 3, because x always comes first when we were plotting points. So this algebraic method worked. So I wanted to share some reflections from doing this project. I found it to be really challenging for me to try to put together a lesson virtually. I've done this lesson with my students in person. I just didn't get consent with parents to record them. So we just did the same exact problem together. And I found that my student really liked the algebraic method after doing it for a while. And then I also found that some students liked the more visual method. It's really important to show all 3 methods and in math so that the students can kind of resonate with the way that they like the most. And yeah, so that's kind of been a theme in math, is showing different methods and ways you can solve a problem, and then building confidence in each area. And then when it comes to test time, the student can really choose which method resonated with them to kind of solve the quickest or the most efficiently. But yeah,